Hello and welcome to Mrunal's math tutorial. In today's tutorial, we are going to look at permutation and combinations, and these are the following objectives that we will be looking at. Arrangement with objects together, separately, not all together, placing the values in different positions, selections with different objects, selections with repeated objects, and splitting into different groups. Thank you for watching my video, and if you haven't liked, shared or subscribed my channel yet, please go ahead and do that before I begin with the questions. Let us look at the first question. In an orchestra, there are 11 violinists, 5 cellists and 4 double bass players. A small group of 6 musicians is to be selected from these 20. How many different selections of 6 musicians can be made if there must be at least 4 violinists, at least 1 cellist and no more than 1 double bass player? So let us write down what has been given to us. So we have 11 violinists, 5 cellists and 4 double bass players. Now the condition given to us is that we should have at least 1 cellist, 4 violinists, and no more than 1 double bass player. Okay, so let us understand the meaning of the word at least. At least means it can be 4 or more. No more than 1 means it can be 1 or 0, less than 1. So in this manner, we need to select 6 musicians over here. Okay, so this is our first selection, 411. Let's say we do not select any double bass player. In that case, we can add another cellist, for example, and we keep the number of violins the same. Or we can have 5 violinists, 1 cellist and 0 double bass players. So I think these are the different selections that we can have. Now we need to calculate what is the total for these selections. So let me just move this onto the left. So from 11 violinists, I need to choose 4. So that's going to be 11 choose 4 times from 5 cellists, I need to choose 1 cellist. So that's going to be 5C1 times from 4 double bass players, I need to choose 1. So 4 choose 1. If you calculate that, it comes out to be 6,600. Likewise, let us calculate the remaining. 11C4 times 5C2, 4C0. This works out to be 3,300. The last one, 11C5 times 5C1 times 4 choose 0, and this works out to be 2,310. So total of all that is equal to, let's calculate, 6,600. That works out to be 12,210. So this is how we can do selections with different objects, right? Okay. Let's look at the next example. In this next example, it is the second part of the same question. Here, the small group that has been selected now contains, again, 4 violinists, 1 cellist and 1 double bass player. They sit in a line to perform a concert. How many different arrangements are there? Okay, so this is arrangements, that means this is going to be permutation. Or you can use factorial. Right? So we need 4 violinists, 1 cellist and 1 double player, and the condition given to us is that the violinists must sit together. So the 4 violinists must sit together. Let us put them in a block, and then we have 1 cellist and 1 double bass player. So if the violinists are sitting together, we treat them as 1. So this will be treated as 1. So we have basically how many objects to arrange? 1, 2 and 3. So that can be done in 3 factorial ways. 3 objects to arrange, so 3 factorial ways. Now remember, these violinists are different people, so they may decide to sit in different position, but they are sitting together again, but can sit in different positions. So that would be 4 factorial. So the arrangements would be 4 factorial. So if you multiply this together, you would get 144. Let us look at the next example. We have here, find the number of different ways in which all the 9 letters of the word mincemeat can be arranged. Again, this is arrangement in each of the following cases. The first case is there are no restrictions. So if you look at the word mincemeat, okay, we can see that there are 2 M's and there are 2 E's, right? So these are repeating. So when you find the total arrangements, of course the total arrangements, because there are 9 objects to arrange or 9 letters to arrange, we can say that the total arrangement is 9 factorial. Yeah. So, but because the M's are repeating, divide by the repetition, divide by 2 factorial times 2 factorial. This is because E's are also repeating and we have 2 E's, right? So use the calculator to work out this. It should be 90,720. Right. Now let's look at another part of this. No vowel A, E, I are the vowels in the word mincemeat. So no vowels is next to another, no vowel is next to another vowel. Okay, so we have, if I remove, let me just copy this. So in mincemeat, okay, so we have A, E, I, and there are 2 E's, remember, yeah, and 1 I. So these are all the vowels and they should not be next to each other. Okay, so what we can do here is, let us write down the remaining letters. M, there are 2 M's, yeah, let us write down the remaining letters. So there are 2 M's, there is an N, C, T. So basically a vowel should not be next to another vowel. This means that they should go into these gaps. Okay. So this method is called as method of gaps, and you use this method only when we don't want something or the objects to be next to another. Okay. So let us see how many things we have to arrange. We have 1, 2, 3, 4, 5. 5 things to arrange, so that can be done in 5 factorial ways. remember there are two m's repeating, so divide by the repetition times, let us see how many gaps are there. 1, 2, 3, 4, 5, 6. So 6 gaps. So 6 permutation with 4. This is 4. 6 gaps over here, and it is 4 because we have 4 vowels that we need to arrange. So 6 permutation with 4 divided by, again in the vowels the e's are repeating. There are 2 e's, so divided by 2 factorial. This 2 factorial is for the m's which are repeating. Let us calculate that. It gives us 10,800. Alright, so this is arrangement of objects separately. You have to remember that the method of gaps can only be used if the objects or the vowels or whatever it is, they are separated, means not together. Now let us look at the next part of the same question. 5 of the 9 letters of the word mincemeat are selected. Find the number of possible selections which contain exactly one M and one E. So we have 5 letters. In that we have one M and one E. So the remaining 3 could be any other letter. So from 5 we choose 3. That would be equal to 10. Yeah. Why is it 5 choose 3? Because we remove the M, we remove the E, we are left with how many? 1, 2, 3, 4, 5. So 5 choose 3. That's equal to 10. Part 4 is asking us, find the number of possible selections which contain at least one M and at least one E. So we have 2 M's and 2 E's. We should have 5 letters. Yeah. At least one M and at least one E. This is your first selection. It's possible to have both the M's and one E, or one M and 2 E's, or 2 M's and 2 E's. I think that's all the possible selections. So from 5 you choose 3 for the first one, 5 choose 2, 5 choose 2, and 5 choose 1. Calculate each one of them. This works out to be 10. 5C2 is also 10, and 5C1 is 5. So total would be then equal to 35. Right? Okay. So this is selection with repeated objects. Now let's look at the next question. We have over here splitting into different groups. 9 people are to be divided into group of 4, group of 3, group of 2. In how many different ways this can be done? Okay, so we have 9. Let us choose the first 4. So how many people remaining from 9? If you chose 4, we will be left with, from 9 you chose 4. So 9 minus 4, you'll be left with 5. From 5, you're going to choose a group of 3. 5 choose 3 times. Now from 5, you have chosen 3. So how many people left? 2. And from 2, you're going to choose all of them. So 2 choose 2. This works out to be 126 for 9C4. 10 for 5C3, 2 choose 2 is 1. So this is 1260. Alright. So that's very easy, choosing or splitting into different groups. Now this question is very common in the AS level exam. Arrangements with placing values in positions. Let us read the question. Find how many numbers between 3000 to 5000 can be formed from the digits 1, 2, 3, 4 and 5 if the digits are not repeated. So now we know that this is a 4-digit number. So let's say this is a 4-digit number, right? So we have to find how many different numbers can we make or are there between 3000 and 5000. So for the first digit we have two possibilities. We could either place 3 or 4. We cannot put 5 because the number has to be less than 5000. So it would be starting with 3 or 4. So the first place or first position can be filled in two ways. So let's write here 2. So you can take 3 or 4 over here, right? Now remember, the numbers cannot be repeated, right? So if 3 or 4 is gone, to fill up the next position we need to think about it. So let's say if 3 is gone, so the next position can be filled up by the options available for the next position would be 1, 2, 3, 4. Yeah, 1, 2, 3, 4. This is if 3 is gone. What will happen if 4 is taken up here? It would be the same. 1, 2, 3, 4. So the second place or position can be filled up in 4 ways. There is a multiplication in between. Okay. So now we are done with the second position. So if the second position can be filled up in 4 ways, the next position can only be filled up in 3 ways because the digits cannot be repeated, right? And the last position can only be filled up by 2 ways because the digits cannot be repeated. If you multiply this, you would get 48. So how many numbers between 3000 and 5000? There would be 48 numbers. Let's look at the part 2. If the digits can be repeated, okay, and the number formed should be odd. So the digits we have is 1, 2, 3, 4 and 5. Okay, so it is going to be a 4-digit number. Yeah, again it has to be, the condition is the same. It has to be between 3000 and 5000. So the first digit can be filled only in 2 ways. We can start with 3 or we can start with 4. Now, so digits can be repeated. The second position can be filled up in 5 ways. The same is true for the third position because the digits can be repeated. Whereas the last one, we need to be careful over here because it has to be an odd number. So if it has to be an odd number, the last digits can be only 1, 3 or 5. Only then it will be an odd number. So this can be filled up in 3 ways. So if you multiply together, you get 150 ways. All right. Okay. Now let us look at the next question. What do we have here is find the total number of different arrangements, that is permutation factorial, of the 8 letters in the word tomorrow. Okay, so if you have 8 letters, these can be arranged in 8 factorial ways. Be careful that there are some letters that are repeating. I can see that O is repeating 3 times. Yeah, O is repeating 3 times and R is repeating 2 times. So I must divide this by 3 factorial times 2 factorial. 3 for the O's that are repeating and 2 for the R's that are repeating. So what do we get? 8 factorial divided by 3 factorial times 2 factorial, we get 3360. Next question, part B. Find the total number of different arrangements of 8 letters in the word tomorrow that have an at the beginning, R at the end, and in which the 3 O's are not all together. Now there is a difference between not together and not all together. When the word says not together, you can use method of gaps. And when it says not all together, you must only use the method that we are going to see now, which is all minus together. All right. So for separately, or not together, we can use method of gaps, but not all together, we can only use all minus together. Okay, so let us see now. So we have R at the beginning and R at the end. There are 8 letters, so in between we will have 6. 1, 2, 3, 4, 5, 6. That means we have the O's and we have M, T, W. Okay. All arrangements would be, you see how many things you need to arrange. These are fixed, so ignore them. So you just need to arrange 1, 2, 3, 4, 5, 6. 6 things to arrange. So 6 factorial, out of which the O's are repeating. So divide by 3 factorial. And together, with the 3 O's together, would be something like this. You will have the R at the end, O's are together, count them as 1. So we have 1, 2, 3 and this is counted as 1, 4. So this can be arranged in 4 factorial ways. So the final answer would be 3 O's not all together would be 6 factorial divided by 3 factorial minus 4 factorial. That's equal to 96. A common mistake is to confuse and use method of gaps for this one. Gaps will not work for all, not all together. So remember the keywords, yeah, that we have covered in this video. All right, thank you for watching, and hopefully I have cleared your doubts. I would be posting some more videos about permutation if you like, or if there's any other topic you want me to post a video about, please write a comment. Okay, thank you for watching.